This is the Argonauts, our amphibious 3D river mapping entry into the Map the Gap challenge set by DASA and DSTL. This is a surface vessel. It drives to the river using wheels, 8-wheel drive, powered by 48-volt Tesla battery modules. As it enters the river, it then switches over to twin electric thrusters to propel itself through the water to the other side. It can enter the river in quite challenging terrain, controlled through a Wi-Fi telemetry and a backup hand controller. It can operate in up to 3 knots of current safely. It uses 3D multi-beam sonar capable of measuring 50 swaths per second. The vehicle's also fit with 3 laser scanners, a Leica laser which is capable of measuring 1 million points a second, SICK laser scanner which is a shorter range laser scanner covering a gap which we have beneath the vehicle that the Leica laser scanner can't cover. We also have a Velodyne VLP16 laser scanner which can give an instant 3D view of the environment around the vehicle with a 20 Hz update rate. All that is positioned by a high-end inertial navigation system, taking measurements 200 times a second, measuring angles, the orientation of the vehicle down to an accuracy of 0.01 degree. Yesterday we had the ADCP acoustic Doppler current profiler fit to the vehicle, which measures the full current profile through the water column for a full profile across the river or for anywhere the vehicle went. We control the vehicle through a ground control station, acquiring all the data and storing all the data. We can make immediate measurements on a 2D plan view. We can take cross profiles immediately as the data comes in live. We also digitally transfer the data over Wi-Fi back to a PC in our control van. Within a couple of minutes we can view the high resolution data in a 3D environment to make more detailed measurements, get a better interpretation for the environment that we've surveyed. So we've started off easy with the trials. We launched from a slipway in Hale Harbour, ran various loops around areas in the harbour. During different parts of the morning there were different currents, different flows, different speeds of entry, different levels of autonomy testing. Once the tide was too low to work there, we moved over to the beach, a little bit further up the estuary, manoeuvred the vehicle on sand, through sand dunes, using the tracks, and a little bit in some very shallow water on the estuary. Today, we moved over to the river crossing site, grassy area, rocky beach, sand dunes, and a 180-metre river crossing exiting onto the other side onto kind of pebbly, rocky beach. We made various crossings of the river, quite a few trial runs, and then we completed the main challenge of 3 consecutive crossings, and we also completed some runs up and down the river parallel to the riverbanks. We then tested the off-road capabilities, going up sand dunes, slope climbs, various different terrain, dips and slopes and banks with the vehicle on the land. Everything's gone well today. It's a difficult site for this type of vehicle. The tides were running quite strong towards the end of the test, but yeah, a nice environment to put the vehicle through its paces for a proper challenge.